Now let's do a more complex one. I'm gonna look for one out of the book so that I get whole numbers, okay? That's the same example I already gave you. Okay, let's see here. Okay, here we go, here we go. Okay, so we got 3x plus 2y minus z equals -1. X plus 3y minus z equals -10. 2x minus y minus 3z equals -3. Okay. This one's a little bit tougher. I'm going to write out my matrix equation. The numbers go in here, so it's going to be 3, 2, -1, 1, 3, -1, 2, -1, -3, which I'm just getting from the coefficients. Then this is going to be x, y, z, and this is going to be -1, -10, -3. Okay, finding the determinant of a 3 by 3 matrix is a little bit tougher. What you want to do is you want to rewrite the matrix by itself. You want to rewrite the first two columns outside of the matrix. Now notice on the other one we went down and to the right, positive, up and to the right, negative. We're going to do the same thing here, but we're going to actually come outside of the matrix. So that's why we rewrote the first two columns. So we're going to multiply these together and we're going to add them. So we're going to do 3 times 3 times -3 plus 2 times -1 times 2 plus -1 times 1 times -1. Now when we go up and to the right, we're going to subtract it. So now I'm going to go up and to the right. So I'm going to say minus 2 times 3 times -1 minus -1 times -1, whoops, times 3 minus -3 times 1 times 2. So I want to simplify these out. 3 times 3 times -3 is -27. 2 times -1 times 2 is -4. -1 times 1 times -1 is 1. 2 times 3 times -1 is -6, but it's minus a negative, so it's going to be plus 6. -1 times -1 times 3 is 3. -3 times 1 times 3 is -6, but it's minus a -6, so it's going to be plus 6. So that gives me -31, -30, -24, -27, -21. So the determinant of this is -21. Now I'm going to need that on the next thing that I do. Okay. So just like before where I replace the x's when I want to solve out the x's, I'm going to do the same thing. So I'm going to make a new matrix. I'm going to replace the x's with my solution, which is -1, -10, -3. The y's and z's are going to stay the same, so it's going to be 2, 3, -1, -1, -1, -3. Now remember, when I did this, I had to rewrite the first two columns on the outside, and then I'm going to multiply. So these guys are going to be added, and these guys are going to be subtracted. In the interest of time, I'm going to just multiply them out to go a little bit faster. So this is going to give me 9. It's going to give me 6. That's going to give me -10. 59. It's going to give me -1. It's going to give me 60. 9 plus 6, 15, minus 10, -5, -14, -13, -73 over, and my determinant was -21. Did I do that right? 15, 5, -4, -3, -63. Which that's going to equal 3. So x is 3. Now we're going to do the y. We're going to replace the y column with our solution matrix. The z's are going to stay the same, and the x's are going to stay the same. I'm going to rewrite the first two columns. These ones are going to get added. These ones are going to get subtracted. $90, 2, 3, 20, 9, 3. It's 92, 95. 75, 66, 63, so y is going to equal -3. And now the last one is my z. Of course, I ran out of paper. So in the z, I'm going to replace the z's with my solution matrix. The x's and the y's are going to stay the same. I need to rewrite my first two columns on the outside. Multiply these and add. Multiply these and subtract. Gives me -67, -68, -62, -92, -86. Did I do that right? 67, 68, 62, 92. Seems weird that this one would give me something like that goes in. It has to be a 4. What did I do wrong? Why would this one be the only one that gives me a fraction? -27, -40, 3, 2, 1, 3, 3, 2, 1, 3, 2, -1, 3, 3, 1. It should have been +1. Okay, so that gives me -27, -67, -66, -60, -90, -84. That makes more sense, which equals 4. So our final answer is our x was 3, our y was -3, and our z was 4. I know that takes a while, but the more you practice it, the easier it gets and the faster it becomes. And we'll just keep working on these guys. Now there are a couple of special cases, okay? The special cases are when your determinant equals 0. If your determinant equals 0, then that's infinitely many solutions. So we're going to say like this. And then if d equals 0, and neither the numerator or the denominator is 0, meaning you go through the process and we're doing this right here. So where was I? Okay, so if I do this right here and this gives me 0 and this gives me 0, then it's infinitely many. Or if this one gives me 0 and this gives me 0, then it's infinitely many. If this gives me, determinant gives me 0, but neither of these do, then it's no solution. So this one, any other 0, and this one, no other 0. I hope that makes sense. I'm really sorry that it took so long. I'll give you guys time to practice in class, and then hopefully it'll make more sense.